This lesson will teach you how to identify which equation is truly the best fit by using a technique called least squares. Imagine that city planners in the Salt Lake Valley are trying to decide how best to develop the TRAX public transportation system. They have noticed that when gas prices get more expensive, more people are willing to try public transportation instead. They have already collected their data and drawn a scatter plot. Now they need to draw the best fit line to model their data. Unfortunately, there are several ways we could draw the best fit line that all look reasonable. One possibility is to tilt the graph up and go above the final data point. Another possibility is to tilt the graph lower and go below the final point. Each of these possible lines comes with its own equation, which has been written above the graph. Actually, there are dozens of possible lines that we could explore, but to keep things simple, we will only compare these two. So, which of these graphs is the best? Just by looking at them, it's impossible to know for sure. What we need to do is figure out which graph has the smallest residuals. Let's start with the blue line. Using the equation we've been given, we can calculate the fitted values. If I plug 1.5, that is $1.50, into the blue equation, I get y equal 0.9 plus 1.4 times 1.50. Remember that you do the multiplication first, and then add 0.9 to the product. This works out to be 3. Continuing this process, I get fitted values for every data point. The fitted values are just the first step. What I'm actually interested in is how close the values are to the actual value. This means we need to use subtraction and calculate the residuals. Let's look at the first data point in the column called TRAX riders. The first value is 2.1. Take 2.1 and subtract the fitted value. That would be 2.1 minus 3.0 equals negative 0.9. Continuing this process, I can get residuals for every data point. Let's add all these residuals together to see what the total residual is for the entire graph. Unfortunately, the number you just calculated is not as helpful as you might think. The problem is the positives and negatives. The positive residuals cancel out with negative residuals. So our final answer is not nearly as big as it should be. We need to find a way to prevent positive and negative residuals from canceling out. The easiest way to do this is by squaring each residual. Remember that a square means to multiply a number by itself. A square should never give you a negative answer. Let's try it. Negative 0.9 times by negative 0.9 equals positive 0.81. Continuing this process, I get values for every data point. Now that all the numbers are positive, we can add them together. We don't have to worry about numbers canceling each other out. This particular graph adds up to 3.78. That number, the one we just calculated, is called the squares for the graph because we had to square the residuals. When you are comparing two possible lines for a set of data, the line that gives you the least squares is considered the best line. So let's look at the second possible equation to see if the number of squares is better or worse. Pause the video and calculate the total squares for the red line. Then resume the video and check your work. Okay, first we need to plug in all the x values, in this case the gasoline price, into the red equation we were given. This gives us the fitted values. Next we need to subtract and find the residuals. Finally, we need to square the residuals to make all the negatives go away. The last step is to add the squares together. When we analyzed the blue graph, the total squares were 3.78. When we analyzed the red graph, the total squares were 2.84. Remember that the best graph is the graph with the least squares. This means that the red graph was the best fit.